Hi everybody, welcome back. Today we are going to discuss about thermal physics, that is heat and temperature and all. And the main topic is water or vapor which is dangerous. That's our topic. Here I have some question for you. Water or vapor which is dangerous? The question is, there are two containers here, the container number 1 and here is the container number 2. First container is filled with ice cube which is at 0 degrees Celsius, and the second container is filled with cold water. The temperature is also 0 degrees Celsius. So note this two temperature same, the temperature is same, and we immerse the container of water, a water bottle number 1 and the water bottle number 2 filled with water, equal amount, equal volume of water is there inside. Okay, and my question is here, which water bottle will remain cold in temperature for a longer time, that is the question. Is it the container with the ice cube or it is the container with the cold water? That's my question. And everyone, from our daily life, from our common understanding, we know the answer, that is ice cube. The water bottle inside the ice cube container will keep the coldness for a longer time. What is the reason? So the reason we are going to learn. The reason is temperature of ice cube will not change during melting process. So here the important term is melting. Ice melts. Why ice melts? Because there is a heat. Where is the heat? From the water bottle. So water bottle supplies heat. Water bottle supplies heat to whom? To the ice. So what ice does? It absorbs. What it is absorbing? It absorbs heat. Where the heat is from? From the water. Does the water has the heat? Yes. So is it the hot water? No. What is the temperature of water that I have shown in the picture? It might be 25 degrees Celsius. Is it hot? Yes, it is warm. What if the temperature of water is 20 degrees Celsius, 15 degrees Celsius, 10 degrees Celsius? It is below the room temperature, so we feel the water is cold. If you get the water from the refrigerator, the temperature would be 10 degrees Celsius and then we feel it is cold. Does it have a heat energy, the cold water? Yes, it has a heat energy. All the object, whether it is cold or hot, every object has the heat energy. So what is heat energy? Okay, you should know about the heat energy. Now here is a container of water and here I draw atoms or molecules, we can say. And now we discuss about two molecules to know the better understanding of heat. This molecule number 1, every molecules. Okay, now I am discussing about the molecule 1. It moves in a various direction. As it is moving like this, different direction, it will be having some energy. In physics we say it is kinetic energy. As it is moving, the particle number 1 or the molecule number 1, as it moves here, it moves away from the molecule number 2 or towards the molecule number 2. So when the gap between the molecule changes, there will be another energy is there, that is potential energy. There is a potential energy inside the water molecules. There is a kinetic energy inside the water molecules. So this addition of kinetic and potential energy of molecules is known as heat. So which means even it is a cold or a hot, the molecules in water, it moves. As it moves, what type of energy it has? Kinetic energy. As it is moving, the gap between the molecule changes. Okay, so it should have potential energy. So the addition of kinetic energy plus potential energy is equal to heat. So my dear friends and my students, you understood this concept today. A new concept it might be for you. So all the objects, they have heat energy, even it is colder. So the cold or hot, it is not the measure of heat. It is not a measure of heat. This coldness and hotness is known as temperature. If the object is hot, it is called high temperature. If the object is cold, it is called low temperature. Is this clear, my dear friends? Okay. Now we know we have to learn something different important thing here with some drawings. Okay, now we are going to learn about melting. Okay, melting. Now you have 1 kilogram of ice cube. Now I want to change this, excuse me, I want to change this 1 kilogram of ice into 1 kilogram of water. So what I supposed to do? I have to heat 1 kilogram of ice. So what happens? It changes its state. Okay, what is the initial temperature of ice cube? It might be 20 degrees Celsius minus 30 degrees Celsius, whatever. So when you heat it, the temperature increases and finally it becomes 0 degrees Celsius of solid. Until 0 degrees Celsius, the object is said to be solid. This object is said to be solid. Once it reaches 0 degrees Celsius, again you are supplying heat. Then this heat energy is absorbed by the solid to change its state to water. During this process, during this state change process, the temperature remains same, 0 degrees Celsius. If you put this ice cube in the container and then you place thermometer inside. Now here is a thermometer. Sorry, my diagram is not that accurate. Okay, students. Now what happens if you see it, the temperature here 0 degrees Celsius will not change. It will not change during the process of state change. The temperature remains same, 0 degrees Celsius. But actually, if you take any object, if you heat the object, the temperature, if it is 10 degrees Celsius, after some time it will be 15 degrees Celsius, 20 degrees Celsius, whatever, the temperature will increase. But during the state change process, ice is at 0 degrees Celsius, water is at 0 degrees Celsius. After it completely changed into water, the temperature is 0 degrees Celsius. Here the temperature is not increasing even though you supply heat. So this heat is now, we believe it is a hidden heat because there is no changes in temperature. So it is called hidden heat. So in physics, word of hidden heat is called latent heat. Latent heat means what? Hidden heat. Why are we calling this as a hidden heat? Because the temperature is not changing, isn't it? Okay, students. Now again I draw this picture. 1 kilogram of ice cube completely changed into 1 kilogram of water. Is the temperature changes? Is changing the temperature? No, temperature is not changing. What is the temperature here? 0. What is the temperature here? 0. So only changes we can see it is state change. What is state? Here is a solid state and here is a liquid state. During this process we are supplying heat. Okay, to completely change from ice to water we have to supply 330,000 joules of energy if it is 1 kilogram of ice. We need this much of energy, my dear students, this much of energy. Is that clear? Okay. Now, if you want to change water from the water, excuse me, if you want to change from water to vapor, okay. Now another concept. Now here you have a water in the container, 1 kilogram of water in the container, and then you supply heat. So what happens? It becomes 1 kilogram of vapor. So here the temperature will be 100 degrees Celsius, here 100 degrees Celsius. This process is called boiling process. Here the temperature the same as like melting, temperature is constant, but here still we are supplying heat. Here how much heat is necessary? 230 joules. 2.3 million joules of energy per kilogram of water to convert it into per kilogram of vapor. We need 2.3 million joules of energy is required to change from water to vapor. How much I told for solid to liquid? 330,000 joules. Okay. Now how much it is? 2.3 million joules. Million means 6 zeros. 2.3 multiplied by 6 zeros. So it's very high, very high. Why it is needed? 2.3 million joules of energy is needed because the liquid molecules are closer. Liquid molecules are closer. Water vapor molecules are far apart. So you have to cancel. You have to break the force of attraction. There is a force in between the molecules. This force is very strong in the liquid. If you want to change into vapor, we have to break all the bonds of the molecules. So you have to supply 2.3 million joules of energy. It is the reason what when we use steam. Now you have a pressure cooker, and then here if you open the pressure cooker, suddenly the vapor comes out. When you put your hand here, your hand here, you feel very pain. It scald our hand. If another example, if sometime on your body a hot water spills, you won't feel that much pain when the vapor falls on your body. This will be very dangerous. The vapor is very dangerous because it releases 2.3 million joules of energy outside. So if you go to a hotel, a restaurant, where you can see if they want to heat the milk, they use, nowadays they are not using a stove or the heater, they are using a vapor, okay, to heat the milk faster because it gives out 2.3 million joules of energy. This is a very big amount. So the steam is dangerous. It is because it has very high energy, like 2.3 million joules of energy. Is that clear, my dear students? Okay, hope you understand this concept. If you have any doubt, further question, please don't forget to post your comments. I'm ready to answer for all your questions. Thank you very much for your continuous support. Bye bye.